A furnace running 1,700 degrees Celsius for 8,000 hours a year. Resistance heating coils threaded into parallel ribbed channels. Each rib carrying 15 kilovolts per millimeter of dielectric load and supporting molten aluminum thermal exposure underneath. Standard alumina porosity allows moisture, iron migration, and dielectric drift over time. Refractory firebrick chips and crumbles under cyclic thermal stress. The 99% high-purity alumina insulating base carries all of it for the full life of the furnace. 6 features anchor the engineering case for high-purity alumina insulating bases in furnace duty. Bulk density between 3.85 and 3.92 grams per cubic centimeter, significantly higher than standard 96% alumina at 3.6, the densification level that closes off the open porosity and eliminates moisture absorption. Flexural strength between 350 and 420 megapascals, holding the structural support load across 8,000 thermal cycles a year. Vickers hardness between 1,600 and 1,800, resisting abrasion from heating element coils and oxide scale formation. Dielectric strength between 15 and 18 kilovolts per millimeter, supporting the interchannel isolation that keeps adjacent heating coils from arcing. Volume resistivity reaching 10 to the 14th power ohm centimeters. 2 orders of magnitude above standard alumina, the insulation quality that holds across continuous high-temperature exposure. And maximum continuous service temperature between 1,650 and 1,700 degrees, the operating margin that survives furnace temperatures where 96% alumina starts to creep and refractory firebrick crumbles. 3 purity tiers separate the alumina ceramic family, and the gap in performance between them is significant. Standard alumina at 92 to 96% purity covers general industrial parts. Density around 3.6, relatively high porosity, dielectric strength around 10 to 12 kilovolts per millimeter, working temperature ceiling near 1,400 and 1,500 degrees. High purity alumina at 99 to 99.9%, the grade used for furnace insulating bases. Lifts density to 3.85 or higher, drops porosity to extremely low levels, raises dielectric strength to 15 to 18 kilovolts per millimeter, and extends continuous service to 1,700 degrees. Ultra-high purity alumina at 99.99% and above is reserved for semiconductor wafer processing and plasma chamber components. The 99% grade is the engineering sweet spot for thermal equipment. Dense enough to eliminate moisture-driven dielectric drift, pure enough to resist plasma and aggressive process gas exposure, and cost-balanced enough for large structural base parts where ultra-high purity would be overspecified. Alumina insulating base parts cover the dimensional range from compact instrument insulators through large multi-channel furnace heater support assemblies. Standard tolerances hold within plus or minus 0.02 mm after precision CNC grinding. Beyond standard formats, 5 customization pads shape the base to the drawing. First, special dimensions. Extra large or extra small footprint, non-standard thickness, ultra-long or ultra-short axial profiles to match equipment-specific mounting envelopes. Second, geometry feature. Parallel rib channels for heating element threading, slot widths and depths tuned to coil diameter, drilled holes and threaded mounting features integrated with the base profile. Third, purity grade selection. Matrix composition adjusted across the 99 to 99.9% range to match dielectric and plasma resistance demand. Fourth, surface finish. Ground or polished surfaces to achieve roughness below 0.4 micrometers for clean contact at heating element interfaces. And fifth, laser marking and batch traceability. Each base carries a manufacturing code for batch tracking across multi-year furnace service intervals, supporting maintenance scheduling and replacement planning. Inside an industrial high-temperature furnace, the alumina insulating base supports the resistance heating elements that drive the entire thermal process. The parallel ribbed channels hold individual heating coils, the inter-rib walls insulate between adjacent coils, and the base matrix carries the structural load of the heating module across the full furnace service life. 5 engineering features make 99% high-purity alumina the right material for this duty. 1700 Celsius degree continuous service. The high-purity matrix holds dimensional stability where standard 96% alumina begins to creep and refractory firebrick chips under thermal cycling. 10 to the 14th power ohm centimeters volume resistivity. 2 orders of magnitude above standard alumina, the resistivity margin that prevents interchannel current leakage even after thousands of operating hours. 15 to 18 kilovolts per millimeter dielectric strength. Supports compact rib geometry between heating channels without arcing, enabling more heating coils per unit furnace footprint. Low porosity matrix. Extremely low open porosity eliminates moisture absorption, iron migration, and the dielectric drift that ages standard alumina insulators over long service. Plasma and process gas resistance. The dense, low-impurity matrix survives reducing and oxidizing furnace atmospheres without degradation. Across sintering furnaces, tube furnaces, aluminum melting equipment, and continuous thermal processing lines, the high-purity alumina insulating base holds the heating element where every alternative material runs out of margin. Ultimately, the 99% matrix delivers what neither refractory firebrick nor standard alumina can match: stable structural and dielectric support at 1700 degrees across the full multi-year furnace service life.